Hello, everybody. Hope you guys are doing well. So this is my third time recording this, but third time is the charm. So in this video, I will be going over the Obelisk project and going over the GitHub repo and some of the code and our initiative that we're doing and giving you guys a global overview of this project that we're working on. Whether you're a developer, a trader, a buyer, a marketer, anybody, whether you know about coding or don't, whether you know about AI or you don't know about AI, I think this is all relevant to you. And I hope to keep this short and sweet and interesting and try to get you guys excited about this project. So, we're working on an open source GitHub repository, which is part of our project, which is a Python framework for building AI agents with a self-hosted LLM and memory layer. So it's been heavily inspired. This project is heavily inspired by Moltbot, aka Clawdbot, OpenClaw, Moltbot. We love their open source initiative and they have an insane repository, but they're focusing on more of the tooling layer because for their project you connect to a state of the art model and then it gives it a good amount of ability and opportunity in that sense. But we are honing in on the memory layer for artificial intelligence, specifically on the weights and the Laura's and trying to work with the actual models and see how far we can take the actual model before, just customizing the context or creating tools around it. We're really honing in on uh, creating a chain of agents, whether it's a couple of memory recall agents, judge agents. So the idea of this project is to give you a framework to where you can just plug in any large language model and from there be able to self host any agent for any task. So agents are very useful for small tasks. For example, categorizing user interactions and certain things like this. You a lot of times are you would use an API like Mistral AI for Mistral agents, but we are essentially empowering you by creating this framework to where you can just boom plug and play and instantly set up your own local agent for under 400 megabytes in memory. So super low key using an SLM, we're using LLM technology, but we're using under the hood SLM, a small language model, Qwen3 0.6b parameters. We called LLM. Actually, we should change it to SLM. So, right. Let me just give you guys a demo. So you can run this in your terminal. You follow these commands. You clone the repository. You set up the Python environment. You install the requirements, and then you can run Obelisk core chat just like this, and it will get started, it will set up the LLM. Everything is locally hosted the first time, and we'll download it from Hugging Face, but you don't need any API keys or anything. Once it downloads the model, it will cache it and use the cached model. Again, everything is going to be locally hosted. Once it's set up, it should be super quick, and you can say hello, you can start typing with it. Might have some issues here with memories. We're still working on. This is a little bit of a debug version, but it's a relatively cohesive model that's able to respond to you really well. And the best part about this is it's more like an SLM, a small language model, because it runs in under 400 megabytes of memory. So solve this equation. X plus 5 equals 7. What is X? So this is just a basic way of trying to figure out if it's able to do some basic math, and it is pretty coherent and cohesive in the sense that it's able to communicate and do some very basic tasks, which is very useful for agents if you're trying to set up some basic agents like memory categorization or user input categorizations or any sort of natural language processing NLP tasks. These agents are amazing at this with a small model, super cheap. You can run multiple of them. With a MacBook M4 Max, you have like 32, 64 gigs of RAM, right? With 4 gigs of RAM, you can be running 10 of these agents to do all sorts of stuff, whether it's coding, right? So you can, if we abstract this away, we don't want to use a Qwen model, maybe some open source coding specific model, um, then this would be a perfect use case for us. And the best part is 100% free. And it's relatively fast. We're actually under the hood. So let me go ahead and you guys can play more around with this if you set it up. And we'll also have a web interface when this is live. But for now, let me take a closer look here at the actual repository. So once you get everything set up, we're testing everything right now only in solo mode. And when it comes to actually testing our CLI and stuff, we're just testing in a chat. testing the chat mode just to make sure that the agent is. I mean, when we first started, the agent was even saying nonsense. It was repeating itself and all sorts of stuff. So right now, it is at least pretty coherent. And so at this point, we're just testing it with the chat. And let me go over exactly the parts of the repo of kind of maybe the basic architecture of the current framework. So the main kind of entry point at this point, we have either API or CLI. So for the CLI is when you're doing chat mode, you're going to have this entry point. And the only thing that it's really doing here is doing some logging. Then it's printing out the template text, some status, welcome, welcome, and then you have the main loop here with the interactions where it takes the user's queries, it shows the thinking indicator, and so what happens first is, as you can see here, is after a user query, it will check, it will get it needs to get conversation context. So when it sends the user's query to the LLM, you see, it needs to run memory selection. So it uses the memory agent here. We have a memory layer with the memory manager, and there's some sub agents here. And one of them is we have two memory agents essentially. We have a memory creator and a memory selector. So every n amount of messages or every n amount of interactions, and interaction is a pair of messages. So every 3 interactions for now, it will take those interactions and summarize them into one key point, aka a memory creator. And then it will store that memory into an activities.json file, which you can check in your project directory. It will be created and it's not committed to Git. So once you start up the chat mode, it will create an activities.json file. So that is the memory creator, which runs after every n amount of interactions. But the memory selector, this one runs on every interaction. And that's what's happening right here when it's essentially getting the conversation context. Well, it's going to have to, there's 2 parts to the conversation context. First part is just the last 10 messages or last n amount of messages. It just includes it. And in addition, we have relevant memories, which come from the memory selector agent. Now, memory selector, the way it does it, it loads the same SLM or LLM model, the Quen 3 0.6b, and it just gives it a prompt to act as to take a list of memories and select a couple of relevant ones, so top 5. And we only take the last 30 memories, obviously, because if you can't just give it an unlimited amount of memories. There's some context window. So we give it the 30 last memories and it will select the relevant ones. And that is all included in the context. So that kind of goes back to here, in the main point where we have the memory manager, right? With the chat mode. Yep. In chat mode here, we got to the context part. So essentially, after it sends the user query, it will do all of these memory operations. And once it gets the relevant memories or relevant conversation context, at that point, it essentially passes the data pipeline, kind of goes through the LLM right here. So the memory layer, we kind of discussed it already, the creator and selector. And now this the main operation of the agent is the actual LLM. So this is where it loads the model and it loads it in quantized mode. So again, it's optimized, it's pretty optimized. Right now, we're trying to keep it as lean as possible. It will also possibly load a LoRa, which is the next part I will talk about, and is the next part we are working on. And besides that, it will just, the main function here is the generate function. It is a God function that needs to be refactored, and we are going to refactor this as well. And the generate function, essentially, again, it gives it a system prompt of what the agent is. We have a config file here that gives you a couple of different, has a couple basic configurations that you can use and set, like setting the port. It also includes the agent prompt. This is the main agent prompt, which we also will modify, and we're happy for the community to help us adjust. It's not very good right now. It's just very basic. It tells it who you are and what it should do. This can be heavily modified. This can also evolve. This can also be updated once every 24 hours or there's a lot of cool stuff you can do with the agent prompt, but we just kept it super simple for now. So these LLM stop sequences can probably be removed as we don't really use them But that's another thing. So where were we? We were talking in this Obelisk LLM. So we have the config file, we have the system prompt, we have some configurations here. Again, the main part of this is the generate function. Now for the quantum influence, this is a part of the quantum layer. We haven't actually integrated this because it's relatively trivial. This is more part of our conscious AI research that we're doing, which I'll talk more in a little bit. But for now, quantum influence, you can treat it as just a random number that influences the temperature of the model, which is what we're doing. This can really be simplified, but for now, we leave it like this. Repetition penalty, I'm pretty sure that Quant 3 does not have this. So there's a couple of optimizations. We're still going to be doing some refactoring here, but for the basic architecture, this is the main agent essentially lives inside the LLM. So besides the conversation context, it's just gonna add some messages and apply some templates, do some token verification, make sure we not exceeding our tokens, and then it's gonna do the actual inference. We have some filtering of the response, and then we return the response. So again, the kind of flow here, it goes with when the user sends the and the message, let's say through the CLI, it'll go through main, it'll go through these memories, it'll go through the memory layer, through the memory manager. It will either create a memory or and it will select a memory. And we also have the recent buffer for the recent amount of conversations. And then it will pass this whole context to the LLM, which will then process it and respond. Once it gets the response, it just spits it out. Sometimes it gets the response and it creates the memory after the response. So this memory creator might happen after. Yes, the memory creation will happen after the LLM response, because it needs to have the full interaction, but it will check if it needs to run the memory creation. And that's pretty much all we have right now. Now, the next step we're working on, first of all, we're working on refactoring this LLM file a little bit more. There's, as I mentioned, there's a couple more refinements we can do here. But the main part, we haven't added any new features. We have just been refactoring things mostly. The next part we're going to work on is the actual lore and the training. The way it works is we have the training, which will just take our data sets. We can have some data sets here, and the LoRa trainer will essentially give it a pair of user and model outputs, user inputs and model outputs of how we would like the model to respond, and then it'll just run an epoch or a couple epochs to train on that data set. The data set does not have to be super large because you're just fine-tuning some LoRa, some low rank rank adaptations, which means you can get away with probably 200 pairs of interactions, which can easily fit into a JSON file. And if you wanted to push it, you can go 1,000, even 2,000 to give it a real nice LoRa. So LoRa's are meant to give the LLM some domain knowledge, whether it has to do with mechanical engineering or, let's say, with blockchain contract auditing or some other things. But we're working specifically on the NLP types of domains in a way. So you could specify the LoRa for any sort of domains, but in our case, the domain knowledge would be knowledge about the user or users in general. So because we're technically trying to optimize the model for engagement, our fitness function or our LoRa will just be a way to get more domain knowledge on the user itself. So in this case, it will take all these conversations. What we're thinking of, we still haven't fine-tuned this exactly, but we're thinking of, instead of taking raw conversations, we could take memories, right? Because they're already essentially summaries of key points of conversations, and we can convert memories back into conversations and feed that into the LoRa. So this will allow your agent to evolve based on your conversations. So it will learn some facts, and the domain knowledge it will gain will be about you. And the best and cool part about this, LoRa is kind of our superpower, which we mentioned before. It will allow you to, in a way, embed direct memories about you into this model. And this agent will respond in creative ways. And in addition to that, we still are going to be adding this super granular memory context to each input. And so far, we've already got some really good results with such a small model. And you can only imagine what will happen when you expand to a 10x or even a 100x larger LLM model. So this, I hope, covers most of everything about when it comes to this repository and just some of the architecture that it involves. Again, if you guys would love to get involved, I kind of mentioned a few things already that we can work on, including how do we select the memories. Right now, it just takes the last end conversations and select and summarizes them. But I'm sure we can have another layer maybe to look at our current memories, and maybe we like can almost even right now we almost in a way model the human brain where we have the frontal cortex where it kind of filters some memories, or we have certain parts of the brain that filter memories, then we have a part of the brain where it selects memories. But now we can have a way of, like, let's say we define some sort of maximum amount of memories that we can hold inside of a context. And the whole idea is we have another layer where it just takes all the current memories and maybe relevant memories and makes sure condenses everything into more of a longer term. We can have split our memory layer into a short term and a long term memory context, for example. So there's a lot of cool things you can do and abstract away. But right now we're keeping it super simple and super basic for those people that, if you guys want to either just get involved into this, so make it easy to contribute, or if you want to even fork this into your own repository and adapt this for your own project or um, ideas, we're more than happy. So hopefully this kind of covers everything. And now let me just go back a little bit to the actual AGI, to the actual platform and what we're trying to accomplish besides just this. This is our open source initiative that is fully part of our Obelisk core. But for the website, for example, we also have an API in the front end, and we also have NFTs, we have a contract, we have a token. So let me just give you guys a brief overview of that part of the project. So right now we're in stage 1. This is the Obelisk, is a crypto project. It's going to be launched on base chain via the Cabal. Cabal is a complete crypto launcher. We're working with a lot of cool projects like Shib. We have a lot of if you look at the Cabal here, we have a lot of cool projects that ran with us. We got quite a bit of volume, and we're more than happy to get. We would love anyone and everyone to launch their projects on the Cabal, but we've been launching through the Cabal because they offer a very nice V4 deployment system. So you can deploy through a V4 hook if you wanted to. You can deploy on V4 with a custom hook, which makes it super cool to be able to deploy our reflection NFTs. So the cool thing about these NFTs is they are reflection NFTs, and they will collect reflections in energy and in base ETH. So we're gonna have our token launch on a V4 with a V4 hook that connects to this river. Now, how does this connect to our AI agent? So you will need to own one of these NFTs to actually interact with our complete AI agent that's going to be on our website, just like you can do it through the terminal, but you will be doing this through the AI agent, through the website. And each NFT is actually has a real quantum seed embedded in it with proof of the calculation that is done through IBM Quantum. And that is here you can see when it is minted. You see there's a job ID, and this seed has been generated through IBM Quantum along with our back end, along with the back end that was used and the qubits that was used. It's always two, and the execution time, how long it took to actually execute. So it's super cool. We're really excited. So each NFT is procedurally generated. That's why it's a random uh, orb here. It's random. It's based on the seed. And we have a couple of NFTs for sale. All of them have been minted already. It's been a very quick mint. We only had 100 supply, and the reflections will be distributed among the 100 NFTs. So when we launch with the V4 hook, if you look at the actual contract for the NFTs here, is this the minter or the, yeah, this is the minter. So the way it was minted, actually, it was minted through this minter contract, which we had to use a real back end to mint it because we had to essentially run the calculations off chain and then add all the information and the proof of calculation on chain and then make the mint. So the contract was minted this way, but the actual NFT contract, you can see here, we have the reflections built in, but they're going to be running through the V4 hook. So while it does have a record reflections function, which will be called from the V4 hook to record reflections, there's no like real, it doesn't run through the NFT itself, right? But So that's just how the actual tech works. All the tokens will be deployed to V4 with the LP fee, and the LP fee collectors are the 100 NFTs. The only other cool mechanic we have is we have a stage elevation mechanic where each NFT starts with a stage one, but an NFT can upgrade the authorized upgrader. So only one contract can upgrade the stage of the NFT, which increases its reflections, as you can see here, based on the stage weight. Based on the stage, it gets a higher weight for the reflections. So again, during each swap, the reflections mechanic selects 5 NFTs at random, and based on their weights, that's how those fees get distributed between the 5 NFTs. And so again, the NFTs are tied into our ecosystem by allowing you to interact with your agent, and also it will be able to, your agent will remember everything about you, and it will just only work for NFT holders. It's hard to scale to 100. We want to keep it small to 100 users, make sure we can scale it to 100 before we go even bigger for a next collection or anything like this. So all the NFTs have been minted, but you guys can find them on our marketplace. Some are listed a little bit higher than others, just depending on you know, the number of the NFT, because right now all of them are stage one. But you can snag one up for 0.01 ETH, which is really good. If you do the math, 2% LP fee, let's say we get 500K in volume, that's about 10K in fees, split around across 100 NFTs, that's $100 per NFT, $50 in ETH, $50 in energy on average. So each NFT should be worth at least, 60, 70, 80, $90. Right now you can grab them for about $30, which I think is a great opportunity. There's only one or two for sale. There's a reason why we have a lot minted and not a lot for sale. People don't want to get rid of them. We actually got it minted for the whitelist. It was $3 to get on the whitelist, so that's why people are selling it. We do have a little bit of some activity here, but the thing is we don't have a lot of people listing him. As you can see, people are canceling their listings and they don't want to really sell them because everybody is waiting for the token launch. And the token launch, we still don't have a specific date planned. But if you guys want to get involved, again, we're giving you plenty of opportunities to grab an NFT. And we would love for you guys to check out our GitHub repo, whether you are, looking into just learning about LLMs. It's fully 100% open source and free. A really great tool to have, especially if you're offline and you need to, have some questions or anything. And the best part is it runs really lean. And the last part I wanted to mention is like the bigger picture for this project. So the Obelisk, the bigger picture is kind of the whole vision that we started with, is to do a little bit of consciousness research with AI, following the popular theories of Roger Penrose and Stuart Hameroff. I'm not sure if they're popular, but they are solid theories about consciousness. And Stuart Hameroff's idea is more about microtubules and how a quantum process has something to do with creating consciousness. And what we're trying to test is if we create some complexity through our AI agent and add some quantum influence through quantum calculations and through our quantum integration, can we give the agent some moments of awareness? So the way we plan to do it is by introducing quantum influence through real quantum calculations, either through quantum mode, which will allow us to run a physical calculation by collapsing the wave function of physical qubits, getting a result, using that result to influence the agent's actions. Just like when you decide to move your arm up and down, you decide to do it. In your mind, it feels like you decide to do it. And maybe Stuart Hameroff and Roger Penrose's ideas are somewhat related to the fact that maybe that decision has something to do with a quantum process. So that is the bigger picture. I hope to get everybody excited. We're building a conscious agent. We're focusing on a very small and specific part of and layer of the agent. We're not trying to make the agent do everything. We're not trying to make the agent super smart. We're just trying to focus on a very specific behavior. Maybe make it feel emotions. Maybe give it some continuity. There's a lot of different cool theories about consciousness, and we would love to actually, as engineers, as devs, to put some of these ideas to the test, but at the same time, creating a solid platform that can be abstracted and used by the masses. So, thank you guys all for checking this out. I hope to get you guys excited. Follow us on X, the base Cabal, the Obelisk AI. Make sure to tune on to our Telegram channel and keep it skibbity, guys. Peace.